Hi, welcome to the video on Titration Lab Explained. We're going to start with the purpose of the lab. So in your lab document, if you read the last sentence of the overview, it tells you the purpose. You're going to use an acid, which in this case is HCl, of a known concentration to standardize or determine the concentration of sodium hydroxide. For that, you're going to have two pieces of information. The theoretical concentration of sodium hydroxide, which is 0.1 molar, the known concentration of HCl, which is also 0.1 molar. So you're going to use the concentration of HCl to check to see if the concentration of NaOH is 0.1 molar. In the data section, there are two rows that we're going to eliminate, initial pH and final pH, because in the data lab we didn't have pH paper. So you can just go ahead and delete those rows when you copy this data table into your lab report. I would also recommend adding an additional row, which is the concentration of NaOH, because those are the calculations that you're going to come up with, and it's sort of the purpose of the lab. So I would definitely add this final row. And then for each trial, you're going to use the information your data to determine the concentration of NaOH, and then take an average concentration of NaOH. So how do you do that? Calculating the concentration of NaOH requires you to use this equation: molarity is equal to moles of solute or liters of solution. And this is essentially a stoichiometry problem. So our very first step is to convert the molarity of HCl into moles of HCl. And you should have used 10 milliliters of HCl for each trial because we use the pipette. And the concentration of HCl is 0.1 molar. So you're going to use these two values, plugging them into this equation appropriately to calculate the moles of HCl. So once you have your moles of HCl, you can now use the molar ratios of the balanced equation, which you've written down in analysis question number 1. So use the molar ratio and to convert from moles of HCl to moles of NaOH. So once you've completed the second step and you have your moles of NaOH, now the final step is to calculate the concentration of NaOH. Again, we're going to go back to this equation up here. You're looking for molarity in this case, that's your unknown. You know the moles of NaOH, and you know the liters of solutions. The liters of solution is comes from the volume of NaOH that you used for that trial. All right, now on to the analysis question. There are some corrections here, and I apologize for that. This lab initially was done where you were to determine the concentration of acid, but we switched that around. So for question 4, at the bottom where it says calculate your percent error based on the known concentration of your acid, that's that should be percent error based on the known concentration of your base. So go ahead and make that correction. I'll show you again for question 4. It's cross out acid and replace it with base. If you're looking at this online, I've already made that correction. So let's talk about that question itself. Percent error is absolute value of theoretical yield minus experimental value over theoretical yield times 100. So what is the theoretical value? The theoretical value for the concentration of NaOH is 0.1 molar. That's what it should be. So you're just going to plug in those values. Now the experimental value of NaOH is the concentration of NaOH that you calculated from your experiment. And that's going to go here. The last part of the lab is error, where you need to discuss the error that's in your lab. So right before the conclusion, you discuss your error. Again, there's a couple of corrections here, so I'm just going to point them out. Starting with error question 1, how would this affect the concentration? Shouldn't say acid, cross it out and replace it with base. And the same thing for number 2, how would this affect the concentration of acid? Cross it out, it should be base because that's what you're looking for. So for the error section, what you need to do is you need to describe at least 2 sources of error and how it will affect your concentration of NaOH, the thing that you're calculating. These questions are sort of like to guide you into like, well, if you did something like go past the equivalence point, which I think everyone pretty much did on in the lab, and it's a common mistake to make with a titration. So if you go past the equivalence point, how would this affect your concentration of base? For this first one, you need to consider what happens to the volume, like the actual volume that you use versus the volume that should have been used, and how would this affect your calculations for the molarity of your base. The next one was if there was leftover water in the burette during the titration, how would this affect the concentration of the base you calculated? So for this one, if there's leftover water, that's going to affect the concentration of the actual concentration of base that you're using. And so if and the way it'll affect that is that it'll change the volume of base because there'll be water in addition to the base. So you need to consider how would that affect the concentration. You may also think about other sources of error. For example, you used a pipette to measure out HCl. Did you do that appropriately? What would happen if you measured out more than 10 milliliters because you went over the line of the pipette? What if you measured out under 10 milliliters because you went under the line? So all of that can be sources of error that you can also consider. But the key is you have to describe the error and appropriately describe how it will affect your concentration of NaOH. If you have any questions, you can shoot me an email or give me a call. This lab report is due at 11:59 p.m. on Friday, which is tomorrow. Hope you found this video helpful. Have a quality day.